So there's many ways to play around with prime and composite numbers, and just a reminder about the two of them. A prime number has exactly two different factors. And a composite number has more than two. And one way to start playing around is to identify numbers that are composite, and then what's left over should be prime. So I'm just going to start this sieve here. And a sieve is something that strains things out, like a colander strains the water out for spaghetti. And so we're going to cross out, strain out the composite numbers, and we'll be left with the prime numbers. So I'm going to start off with, I'm going to let my 2's be red. And aside from the first one, 2 is the first multiple of 2 with the counting numbers. So I'm going to circle that one. And then the other multiples of 2, I'm just going to cross out a horizontal red line. I'm not going to do all of them. I'm just going to go for the first couple rows here. And then I just keep going, crossing them all out. Once I'm done with the 2's, 3 is the next number on my list. I'm going to switch to green, and I'm going to circle 3 because it's special. And then multiples of 3, I'm going to cross out. I'm going to use green. I'm just going to go a different direction. So 6, 9. Now 6 was already crossed out, but I'm crossing it out anyway again. 9's the first number, 3 gets to cross off the list. And then we have 12, which is already crossed off. 15, which wasn't yet. 18, and then we just keep going and get all the 3's out of there. And then you color code however you wish. I'm just going to do a couple more. Let's say we'll do the 5's as blue. And so 2 and 3 didn't get to cancel out 5, so 5 is special. Didn't get kicked out, so it's prime. And then multiples of 5, I'll do a blue diagonal. And I just keep going, getting all the multiples of 5. And sometimes there's a clear pattern, right? All the 5's are in this column here and that column there. 2's are in every other column. The 3's make a totally different pattern that's kind of cute. And then, let's see, I'm running out of colors. I guess I'm going to switch to black here. And then my 7's are special. And first multiple of 7 is 14. It's already been crossed out, but I'm going to cross that out again anyway. I'll put a diagonal the other way. And the next one, the first one, 7 really gets to cross out. No, that's a lie. 21 would have been crossed out by 3, wouldn't it? Let's do that. So 21 is gone. 7 gets it. What's next? 28. Now 28 would have already been kicked off by 2, but I'm going to do that anyway. And then what's after 28? 35, which 5 would have already gotten rid of. But 7 gets to mark it also. And then 42, 2 would have kicked that out. 7 gets to make its mark. And it's really not until 49 that 7 really gets to act on its own and kick the number out of the list. So 49 is the first number 7 got to kick out on its own. So just that's an interesting note. And then keep going, mark off all the other 7s. So you're going to mark off all of the even numbers after 2, all the multiples of 3 after 3, all the multiples of 5 after 5, and all the multiples of 7 after 7. And anything that's not crossed out once you're done doing that, my claim is the rest of the numbers ought to be prime. So give that a shot and see what happens. Now, I'm just going to pick on a couple of numbers later on for fun. So let's say I'm going to pick on 96 and 97. So what about those numbers, 96 and 97? Suppose I don't, finish this and somebody asks me, hey, are those prime or composite? Okay, well, question mark. 96, well, right away I can see that's even. 2 goes into it, right? 2 divides 96. So 96 is not prime. What about 97? Well, we learned some tricks in section 1 to determine if a number is prime or composite. If the ending digit is a 0, 2, 4, 8, or a 6, right? 2 goes into it. If you add the digits, like 9 plus 6 is 15, 3 goes into 15, so that means 3 must divide 96. Because 9 and 6 equals 15, and 3 divides 15. What about 97? Well, it's not even, so 2 doesn't go into 97. So let's switch colors here. Looking for factors of 97. 2 doesn't work. 3, well, 9 plus 7 is 16, and 3 doesn't go into 16, so 3 doesn't work. Now, since 2 didn't work, 4 is not going to work, and any even number is not going to work. So once I rule out 2, I'm done with even numbers when I'm looking for factors. So the next number I really need to check is 5, and I can see it doesn't end in a 5 or a 0, so 5's out. And then I don't need to check 6 because 2 and 3 didn't work. So the next number I would check was 7. And there's no easy test for 7, just kind of do the division. So 7 goes into 97. Let's see, 7 goes into 9 one time. 9 minus 7 is 2. 7 goes into 27 3 times. 27 minus 21 gives me a remainder of 6. So because I have a remainder, 7 does not go in. So 7 doesn't go in there either. How far do I need to look to see if 97 is prime? Well, according to the Civ project, my claim was 7 was good enough. But I'm gonna keep working on this to verify that. So new page. I'm gonna do it in a slightly different way. And I'm gonna actually do 96 first. And instead of just looking at one number at a time, I'm gonna look for factor pairs. So there's several ways to play around with factors. And by that, I mean, I know that 1 times 96 is 96. So there's a factor pair that makes 96. 2 goes in 48 times, I believe. Should double check that with a calculator. And then 3 goes into 96 32 times. So these are factor pairs that make 96. Since 2 went into 96 and left an even number, 4 must go into 96. I think that's going to be 24 times. And again, it's a good idea to check those with a calculator. 5 doesn't go in. Since 3 went in and the result is even, 6 has to go in. So that would be 6 times 16. 7, I'm pretty sure does not, but the only way to check that is with a calculator. So I might as well get out a calculator. Let's try Desmos. And I like Desmos Scientific lately. So 96 divided by 7, I can see is not a whole number. So 7 doesn't work. After 4 went in, it's still even, so 8 must be a factor. So 8 times 12. Let's see, 3 went in and the resulting number isn't divisible by 3, so 9's not going to work. 10's not going to work since it doesn't end in a 0. 11 goes into 88 and 99, but not 96. 12 goes in 8 times, so I'm now repeating myself. So again, I tried an idea for 9, didn't work, 10 didn't work, 11 didn't work, and then I get to 12, which I already have it in my list, so I'm done looking. And 8 and 12 are the 2 numbers that are closest together to get 96. So 2 numbers closest in value. Whose product is 96. Oops, not a question mark, exclamation point. That is a fact. So if you think about two numbers that are closest in value to get a specific number, that's kind of like saying a number times itself. That's as close as you get to get a particular number. So if a number squared is 96, then the number I want is the square root. And it turns out this is a trick that kind of tells us when to stop. So I'm just going to ask the calculator, what's the square root of 96? And I'm going to see it's right in between 8 and 12, not exactly in the middle. It's a different kind of middle than an average. So 9.79, almost 10. And again, that's the number right in between there. So this is approximately 10. So that's about where I could stop looking. So I can kind of use that trick for 97 also. So new page. How do I know if 97 is prime or not? Well, I know I can do 1 times 97. If that's it, it's prime. And I tried so far 2 and 3, 4 doesn't, you don't even bother with 4 because 2 didn't work. We got to try 5. Didn't try 6 because 2 and 3 didn't work, but we got to try 7. It didn't work. How far do I keep going? Well, like the square root of 96 is about 10, the square root of 97 is also going to be about 10. So once I get up to 10, I'm really done. So 7, 8, no bother, don't even have to bother checking because 2 didn't work. 9, we don't have to bother with because 3 didn't work. And then 10 is the next number, and I can clearly see 10 doesn't work. And so I'm going to stop there. Now, typically, the numbers I was checking that I really had to check were primes. And then once I've ruled out that prime, any multiple of that prime is also ruled out as a factor, just because of the way factors and multiples work together. And it turns out the next possible prime would have been 11. 11 squared is 121. And so it's after, numbers after 121 is where 11 matters. And 2, 3, 5, and 7 matter before that. So if my prime sieve here went beyond 121, then I would need to use 11 to rule out any numbers as prime or composite, but it doesn't go that far. So finding out if a number is prime is a hard problem. You have to just do a whole bunch of divisions. There's no easy way around that. It's just a tough problem. And again, to check if a number is prime, it turns out all you really need to do is check primes that are smaller than its square root. And that's a big part of this prime number sieve project, to kind of wrap one's mind around that.